Welcome to Investigation 4.1, Vitruvian Man. So in this investigation, we are looking at body measurements, height versus arm span, and we were creating data tables with that and scatterplots so that way we can look at how everything related to each other. So our focus question for this investigation, if you have data relating to variables, how can you check to see whether a linear model is a good fit? And so we looked at what was called scatterplots on this one. So that was kind of fun. So let's look at a little bit of data. So our data is looking at absences versus math scores. So looking to see if absences and math scores are directly related, if they have a correlation, do they have a relationship, and to see what sort of data that looks like. So we need to make a scatter plot for this data, and then we need to describe the relationship between the number of absences and math scores. So we need to describe the relationship, and we need to make a scatter plot. So I have a graph here to the right, or to the left. So let's start by making the scatter plot. First, we need to create a couple of scales. So we have essentially absences on the bottom, absences, and we have score, math score. And then we need to go from there. It looks like our data for absences goes to 11, and our math scores go to 100. So we're going to break this up in that way. So hold on, a little math magic for you. So that was probably a little jarring, but now we have scores and absences. And so now all we need to do is fill in some data. So if we have 3 absences, it looks like somebody has a score of a 67. So I'll go up from 3 up to 67 and make a little dot. I'll also do it for 5 and 49. And so we'll create a scatter plot of all this data using this same sort of method. So I'm going to pause this and continue to add data so you will see a little bit more math magic. So yet again, a little jarring. Either way, we have this data now plotted. This is the data from from the table. And as I look at this data, I'm seeing that there is a general trend. Looks like definitely math score is related to absences. It looks like we have a fairly steep negative slope. So we have a negative correlation because if you have 0 absences, you'll tend to have a higher math grade. But if you have a high number of absences, your math grade will decrease. It'll drop. So as well, we can also look at this and we can create a line of best fit. So can we create a line that would work? So looking at this, I would maybe want to say, I'm going to use this general area up here and relate it to here. So that's about the line that I'm going for. I want to say that my y-intercept would be the 0.94 point. And looks like we also have another point on here where we have 7 absences, and I believe it's 50. Yep, 7 and 50%. So at 7 absences, the grade is typically 50%. So we can describe the data in that way. So our next question for this, if the data are linear, write an equation for the line that models that data. So now we can write an equation for the line. We had the points 0, 94, and 750 as our data points. So I am seeing a decrease in my rise of negative 44, and my run is an increase of 7. So negative 44 over 7, or that is negative 6.29. Or essentially, every absence is a drop of almost 6.3 percentage points. For math scores. That's pretty extreme. Pretty extreme. So using this bit of data, we're going to now look at residuals. So we have essentially our equation that we are creating is y is equal to negative 6.3x plus 94. So that is our equation. That's our model. So I'm going to rewrite that. Essentially, math score, I can say, is equal to negative 6.3 times my absences plus 94. So looking at this, using this model right here, we can look at residuals and see how well our line fits our data, whether or not it actually fits in okay. So let's practice with this first, maybe these first 3 or 4 points. We have an absence number of 3, so we're going to say 3 times 6.3, negative 6.3, and we're going to add 94 to it, so we get a predicted score of 75. That is a difference, 75 minus 67, of 8. So our math score is, actually we're going to have it be positive 8, is 8 different than what we predict. We're going to also do this next one. We have 5 this time. So we're going to do the same thing. 5 times 6.3 negative times, or plus 94. And we have a 62.5. So subtract 49 from that. That's 13.5 percentage points different. So these various points don't really fit it really well, but maybe another point will. So times, let's try 1 absence. We get an 87.7 or 87.7, which is approximately 9 percentage points off. I'm going to continue filling out this table, so watch the math magic happen. So here we have all the residuals and the rest of the table filled out. As you can see, my residuals on average, if I look at this, I'm going to just make a little mark wherever I see a positive one. I see them occurring more often than I see the negatives. I just accidentally did this. I didn't mean to. And then I also see these negatives, yeah, they're really not happening that much. So quite clearly, my line of best fit is not really a perfect line of best fit. But I can say, based on all of this data, if I were to look at my residuals, I could say on average that we have a 4.29 residual amount. So essentially, I took all of these residuals, I added them up and divide by the number of numbers. So I had 22 numbers, and my average residual ended up being 94.5. I divided that by 22, and I got that 4.29. So my average residual amount is really not that far off. If we're saying that the average kid is getting a 90 versus a 94, that's really not that far off. Either way, that is how we can use residual data to describe our line of best fit. One thing we can say is this line is not perfect, but it does reflect the data. So that's how we can use residuals and concepts of scatterplots, and how we know how to create equations given to points to make a line of best fit. If you have any questions on this, please be sure to ask, as always, and have a wonderful day. Thank you.